Well, folks, I guess we'll start. It is 2:30, and we'll just kind of take our time and ease into this, and people can come in if they want. Good afternoon. Welcome to today's D1 panel session entitled Metadata Provider Perspectives on Longitudinal Data. I'm your moderator. My name is Barry Radler. For a number of years, I managed a longitudinal study of health and well-being called Midlife in the United States, and so I have my own fair share of experience in wrangling data, doing harmonization, and using metadata standards to kind of aid with that. And so, with that being said, I'm going to give some prepared remarks, and then we're going to have brief presentations from our panelists, and then we'll open it up to hopefully a wider discussion at the end. So, Vernon, can you hear okay?
Perfect.
So we want to start off by kind of clarifying our terms. Harmonization is one of these terms that's really been bandied about and used a lot in the last 10, 15 years. And I think it means different things to different people. And there's really almost like a spectrum of meaning. And on one hand, you have, for lack of a better term, I'm calling statistical harmonization. This isn't really what we're addressing here. That's a data concern, right? True statistical harmonization is a data manipulation procedure by which two or more variables are made equivalent for the purpose of statistical analysis. And the goal of that is to minimize any qualifications regarding the interpretability of such analysis. On the other end of this spectrum of meaning, before any statistical harmonization can occur, we must first identify and link presumably equivalent concepts and describe the characteristics of those conceptual, represented, and instance variables by using rich metadata. The process we're discussing here can be variously referred to as harmonization, concordance, equivalence, etc., but it is concerned with documenting study and variable level metadata among similar conceptual variables. And the goal of this type of harmonization really is to provide researchers with well-documented variables so that then they can determine the best way to reconcile or harmonize those variables. In my own experience with the MIDAS study, I found that harmonization is rarely performed, at least successfully, without pain points, and there's substantial effort and investment in this complicated process. And it is complicated because reconciling similar measures that may differ on any number of dimensions, such as different response options, different measurements, scales or instruments, different populations or different samples. A big one is different data collection modes, even different units of analysis. So, and the title of this panel specifically references data harmonization in longitudinal series, in which researchers really analyze change in different phenomenon across time. And key to a longitudinal research strategy is maintaining consistency in data collection procedures, instruments, and samples. This isn't always possible, and in some instances it's not even desirable. So ensuring concordance or equivalency or harmonization among candidate variables becomes central to this type of design and analysis. Another area in which harmonization in itself is so valuable is methodological research. That is, comparing the same conceptual variables that are measured with different instruments under different situations, etc., and determining how these differences actually change the data, how such data can be used or analyzed, and then how we should go about interpreting the concepts these variables are intended to represent. More generally, research data harmonization addresses some of the underlying dimensions of the FAIR principles and the increasing frequency of and need for data sharing in an increasingly connected digital world that we find ourselves in. So harmonization can occur at different points throughout the research data lifecycle, and we've assembled a panel of people and organizations to share their different perspectives and procedures on this topic. As I said up front, each of the panel members will briefly summarize their projects. They're going to highlight the different ways in which they approach this topic. The key theme is to demonstrate how metadata standards, and in particular the Data Documentation Initiative, can provide a framework around which a protocol can hopefully be developed that lends some consistency and replicability to this process. So we'll take one or two questions at the end of each presentation, but we plan to open this up for general discussion once the presentations are done. As it happens, all of our panelists use Collectica software in one way or another to facilitate their harmonization goals. So we're going to start out with a presentation by Jeremy Iverson of Collectica. Jeremy is a co-founder and partner at Collectica, where he helps build software to document statistical data using open standards. Previously, he was a programmer at the Wisconsin Longitudinal Study, working to process, document, and disseminate data for that long-running study. Jeremy is currently an invited expert on the DDI's technical committee. Jeremy.
Hey, thank you, Barry, and thank you, everybody, for being here. Good afternoon. Hey. Going. All right. So yeah, like Barry said, I'm Jeremy with Collectica. We're based out of Minneapolis in Minnesota. We are a software company, and we make software for doing standards-based data documentation. We take a pretty broad view of data documentation. So yes, we can document statistical data, of course, but we can also we also consider survey design, the questions that lead to the data, and those specifications of those questionnaires to be part of a full set of documentation of a survey project. And likewise, information about the study or the process or the workflow that's been used to collect and process all that information, we consider that part of a full set of data documentation as well. So users of Collectica fall into a few different groups. Coincidentally or not, the same sorts of groups that make up the Data Documentation Initiative, the DDI Alliance. So these are like national statistical organizations, research data organizations, which are longitudinal studies like MIDAS and many other ones as well, and data archives as well. So the goals we have with our software and that our customers have, I think, are ultimately to let researchers to discover the data they want to perform research on. Once they find data of interest, to be able to know where that came from. So we think a lot about provenance or lineage. Was it from a survey? Was it from administrative data? Or where did it come from? How was it processed? And then finally, just to be able to allow those data to be more widely used and cited. All right, so thinking of Collectica in terms of performing concordance, we have a few different tools currently available to help with this, and I'll talk a little bit about future ideas for tools we have next. The existing tools, this first one we call Collectica Designer. It's a desktop application that lets you manually create the variable cascade, as you might have heard it, or those different sorts of variables, instance represented conceptual variables. I'll talk a little bit more about those in detail later. You can manually do all of this. I don't think anybody actually does that because it's a lot of work. Collectica Designer also has some functionality to perform this information, or to create this information in bulk. So being able to create a spreadsheet that's much faster to edit, and then bring all that information in at once. We'll take a look in a second at what that looks like. Second tool we have available is the Collectica SDK, or Software Developer Kit, and that's useful for being able to create these variables based on custom import formats, structured information you might already have in a database or some other format, or just on conventions. If your data sets for every wave of a project, each variable has the same name in that data set, that's pretty simple to write a script that says, if it's got the same name, it's measuring the same thing. Or if it has the same name, but it starts with the letter A or B or C, conventions like that, ends with a year number, something like that, Conventions like that can be automated and programmed to create this information very quickly. Finally, we have Collectica repository, which is a metadata repository, and that acts as the central storage place for the concordance information, the variable information, data set information, everything that's required to document this sort of thing. And it also has a web front end that lets people search and browse for this content and to see the concordance across time or across studies. Just a couple of quick screenshots to show, very briefly what things look like. This is an example of a spreadsheet that can be used to bring in concordance. So the first few columns are like the name and the label of the thing being measured. So the age of the respondent, the country where the respondent lives. You can have topics, organize these hierarchically. And then the rest of the columns are just one column for each wave or each time period or each study, whatever you're concording or harmonizing against. So you'll see variables like country 2008, country 2013 for where that respondent lived in a given year of the data collection. You can ingest these spreadsheets into Collectica Designer, and it'll create the conceptual variables, represented variables, instance variables, put them in the correct topics and everything else needed to make this full concordance. When you've done that, this is Collectica Repository's web portal showing a concordance table. This one's taken from a project out of NACTA at ICPSR, kind of showing, I think from the PSID study, some different demographic variables, or marital status variables it looks like, what the variable names are for each year of that study. Maybe a little hard to read in back, but kind of breaks down each individual variable from each data set and links to all the detailed information about each one of those. All right, so our future ideas for concordance tools. Right now, as I said, we have that desktop application. We can import spreadsheets. People have been using this for a long time. There's definitely pitfalls to that. The spreadsheets aren't validated in any way. They are when you ingest them, but while you're editing them, of course, you can put anything you want into that. So we've got ideas for nice web-based editors that'll let people input this information quickly while having the validation of, yes, that is a variable in this data set, and you can concord it to this measurement or conceptual variable. Just to make that whole process a lot faster and higher quality. Secondly, we are exploring ideas to use machine learning to automate or to propose variables as harmonizable. We're definitely thinking of a human-in-the-loop process because we don't want to just assume that the algorithms get everything correct, but to be able to propose these things instead of having to say, here's a variable, which of my 2,000 measurements might this be equivalent to, we think we can really narrow that down to propose a list of a few and just select it much more quickly. And finally, to be able to use common data elements. These are, some people call them conceptual variables, some people call them common data elements. That depends which standards you're used to. But to use some repositories of these common data elements as things to harmonize against. So National Institutes of Health hosts a repository that has many of these CDEs. I know there's other places where common CDEs can be found. So you'll be able to choose your own or create your own even. And then, ideally, multiple projects can be harmonizing against the same set of common data elements, and that can result in some really nice cross-study comparability, we think. All right, and then one last thought just about using DDI and its variable cascade. Barry referred to this a little bit. This is just a little bit more detail on that. For those not familiar with DDI, or at least with its variable cascade, Barry mentioned the three types of variables: conceptual variables, represented variables, and instance variables, or just plain variables. You're probably used to thinking of a data set with the instance variables. An instance variable is a column in a statistical data set. So if you have a column for marital status in a few years, like 3 years, you'd have 3 instance variables. They're really all measuring the same thing, of course. So we have one idea of a conceptual variable. It's simply marital status. It doesn't say whether it's open-ended text or a categorization with 2 codes or 5 codes or whatever. There's just one conceptual variable that says marital status. In the middle, you've got represented variables, and those include the data type. So is it just single or married, or is it single, widowed, married, divorce as options? There's different ways to measure that. So those are the 3 types of variables. And the reason we like this, the way DDI proposes this, is that it's really flexible. So you can use this to document longitudinal studies like MIDAS and many others have been doing for quite a while. It's also super useful for official statistics, so things that might be collected every quarter or every month or every year can use the exact same metadata structure to document that concordance and how those measurements may or may not change over time. It's also very flexible in the sense that it can be used to harmonize or declare the concordance within a single study, like MIDAS, or across studies. So if you wanted to compare MIDAS to National Health and Aging or any other longitudinal study, all of them could concord to the same set of conceptual variables or those common data elements, and that can really assist in discoverability and comparability across studies too. So yeah, we've gotten, I think, really good use out of the DDI's variable cascade, and that's what the next folks who talk are also going to be discussing about how they're using that cascade to perform this on actual studies. So thank you.
Is this working? Everybody can hear me. Are there any questions for Jeremy? Hilda.
Hello, thank you very much. It's more of a comment. In Europe, the FAIR principles are very common. I don't know about in the US how these, like findability, interoperability, reusability, accessibility was the second one. How much that is on the block in the US, but in Europe it is a big thing. And indeed, structures such as the variable cascade are ideal for the reusability aspect of FAIR. So
Yeah.
yeah.
Yeah, I think it's pretty big in the US too. And I think the DDI variable cascade and this whole idea of concordance in general, especially across studies, gets to that. Maybe not the accessibility, but definitely making things findable, interoperable. Is the R repeatable? I forget, but reusable, yeah. Yeah, I think it's good for those three aspects of it, for sure.
Any other questions or comments for Jeremy? Thanks,
Thank
Jeremy.
you.
So the next three presentations are from Health and Social Science Archives. And up next is Sanda Ionescu, who is a metadata specialist senior at ICPSR, where she works to implement and support the DDI. She manages DDI-related projects and serves as the ICPSR representative in the DDI Alliance. Within the Alliance, she also participates in efforts to develop and promote the DDI standard and serves as the chair of the Controlled Vocabularies Working Group.
Oh, okay. How do you open this? Okay. Yeah, I'm good.
Let's do this.
Go on. No, just do it.
Sorry.
Very. I'm fine.
Okay.
Oh, yes. Okay. So I'll just jump into the content because so I'm from ICPSR, and ICPSR's metadata are generally aligned with DDI codebook, which is a different flavor of DDI than what we are using for comparison in longitudinal data. And the DDI lifecycle projects that I'm going to talk about today are entirely supported and published by NAGDA, which is our topical archive for data on aging with funding from the NIA. NAGDA holds a lot of longitudinal data, which are the most relevant and heavily used for studying trends in populations, including issues related to aging. And by documenting variable comparability in these studies, we seek to offer an enhanced user experience, facilitating data discovery and harmonization for secondary research. So we started these projects back in 2019, and to this date, we have completed 3 different types of projects. We have documented variable comparability across waves in longitudinal studies. We have also produced 2 cross-series concordances, and lately we've been working on a multi-series concordance. And in all of these projects, our main objective was to present comparable variables in interactive crosswalks. Keyword searches are available on the Collectica portal, but so far they have not been our main focus. And I've listed here all of the individual longitudinal studies for which we have created comparison metadata. And I think one important thing to note is that we have data from the US, but we also have data from other countries and regions. Tilda has data from Ireland, Halsey from South Africa, and our latest project, CRELS, provides data from Costa Rica. And I'm also describing here the workflow for these projects, but I'm not going to spend too long on this. We basically start out with DDI codebook descriptions of our individual data sets or waves. And then we move on to Collectica Designer, where we create series-level metadata in DDI lifecycle, including variable cascades for comparison and topical groupings to aid in discovery. We have also produced 2 cross-series concordances using both in-house created metadata for the NSHEP study and metadata that were shared with us by the NHATS and MIDAS producers. And this highlights the importance of using interoperable metadata because ICPSR was able to reuse the DDI metadata that were shared with us, and based on it, create new value-added documentation for cross-series comparison. The workflow for the cross-series concordances was actually made possible by the DDI lifecycle structure itself, more specifically the variable cascade, because instead of having to look at all of the variables from all of the waves in the 2 series, we only needed to find comparability at the level of the conceptual variables. And when we found a match, we created a new unifying concept which links the 2 conceptual variables and thus makes it possible to pull together all of the instance variables that are comparable across the 2 series. And I have here on this slide a diagram that shows the final DDI lifecycle structure. And here I have a screenshot of how we present cross-series concordance on the portal. In the initial table view of the concordance, only the unique common concepts are shown, together with the instance variables that are comparable from all of the waves. Another interesting feature in these projects was the fact that we were able to identify 4 different types of comparability. In addition to the more traditional types, we also found quite a few one-to-many and many-to-one matches. And I have here an example of how in one of the series, a broader concept is measured by a single variable, whereas in the other series, 3 narrower subconcepts are measured each with its own variable. So a researcher wanting to compare across series would likely have to combine the 3 variables from NHATS, the second series, into one, and then compare it to the NSHEP variable. The types of comparability are displayed on the portal in comparability notes that are included in the crosswalks. And you can see them over there, but okay. Finally, we have recently been working on a multi-series concordance where we are comparing an HRS subset of demographic and cognitive measures to variables from all of the studies for which we have DDI lifecycle metadata on the portal. The comparison, again, will be made at the level of conceptual variables, and even though we are working here with a limited set of concepts, we think this will provide a valuable overview of how some cognitive measures are assessed across multiple longitudinal studies. And that was it for me. Thank you so much.
Thanks, Sanda. Any questions or comments for Sanda?
I have a better
These are mine. Do we have any comments online, Sarah?
Just a comment from Catherine Lavender, thanking Sanda for representing that.
I took them all.
Catherine just wants to thank you, Sanda, for representing NACTA.
Thank you. Yeah, I lost my glasses, so I would appreciate if somebody can.
We'll keep an eye out for him. So next up is John Johnson. He's the technical lead at Closer, which has been documenting UK longitudinal studies using DDI lifecycle for the past 10 years. He is currently exploring ways in which AI and machine learning can be used to enhance and improve the use of metadata in the data lifecycle. He has been active on the DDI Technical Committee since 2013 and its vice chair since 2016. He's also been co-chair of the annual European DDI conference for the last 6 years, and he was also very instrumental in pulling together this panel. John.
Hi, yeah, so I'm John Johnson. I'm from Closer, which is I'll come on to that in a minute. The slides also helped with by Hayley Mills, who's a senior data manager at Closer, who unfortunately can't be here. What do we mean by questions? So what we're going to cover is what do we mean by questions, what do we mean by equivalence, some examples of our approach, and implementing this in practice. So I hope I'm not teaching people to suck eggs here, but there is sometimes quite a confusion between what a variable is and a question, so I thought I'd spell it out explicitly. So what we mean by a question is it's a way of capturing a concept or a subconcept that elicits a consistent and ambiguous response. And that also applies to measurements. So this is an example of height, where human height or stature is the distance from the bottom of the feet to the top of the head in a human body standing erect. That's from the reliable source Wikipedia. And so there's two examples. What is your height in centimetre? And measure participants' height using a stadiometer and record the result in centimetres. So the first is a question, the second one is a measurement in this case. One on unemployment. So people are classified as unemployed if they do not have a job, have actively looked for work in the prior 4 weeks, and are currently available for work, which is the broadly, and Dan might correct me slightly, I'm sure, the International Labour Organization definition of unemployment. So this could be asked in 3 parts in order to capture the meaning for the concept of unemployment. Do you have a job? Have you actively looked for work in the prior 4 weeks? and are you currently available for work? And that would, so that's an example, if you like, of a subconcept collapsing up into a concept. So one of the things is, why don't you just look at the data? Surely that can tell you how to make things equivalent. The problem is that variable labels are done by different people, are often not very informative and quite often misleading. Multiple response items can be coded differently. So if you've got something that's asking, you've got an option of 3 or 4 things, you could code those in different ways. You could have them as ordered, or you could have them as binary variables, but you're actually capturing the same information. We hold all the metadata for questions and variables in DDI lifecycle already in Discovery, which is our platform. So the question plus sort of contextual metadata, which I'll come to in a second, can help make these decisions in a more, or potentially in an automated way. Even manually, it would be helpful to have that information, but certainly it could potentially, if you've got it in a structure, allow you to make some way of automating that. So this is sort of schematic of how we think about we do. So we mentioned the variable cascade, so you've got a concept, and that's represented by a conceptual variable, and you've got the instance data. And what we do is we use the question or measurement, intermediate between those two, to assess the equivalence between the questions, and that will point to what hopefully is the equivalent concept, and is reflected in data that is equivalent, certainly at a conceptual level, if not necessarily at a represented level. So as I say, it could be ordered codeless, or it could be a binary variable, but for this purpose, this is actually, they are equivalent data in the sense that they represent the same concept. So the sort of caveat around that is, what is equivalent? And as a metadata provider, we have 11 studies. They come from different places, different traditions, so some biomedical, some social. So it's quite a diverse collection of data in our metadata collection. It's very similar to ICPSR and NACTA. But when researchers harmonizing data, they will make decisions about what they think are important considerations to harmonize. So some researchers will, treat methodology very importantly. Some will think that the respondent is a very important part of the response to the question. Others may not. The population or universe can be considered by some people or not, depending on what you're doing, an important factor in whether things are equivalent. The mode of collection, everyone knows now that collecting data on the web and collecting face-to-face, you get very different responses, but in some cases that isn't necessarily a major consideration. And then there's a response domain, so the code list or the way in which the data is represented. So what we've tried to do is to think about the most important thing is actually what was asked or what was measured, and then some of the other stuff around it, we're not going to make decisions when we're providing equivalence to, presenting equivalences to researchers on our portal, making decisions about that on their behalf. We have that information provided in the metadata structures on our portal, so you can do that and make those decisions yourself. And we can point, we point at it not very well at the moment, but we can make improvements on the way we point to that information to allow the researcher to make some considered decisions, depending on their research question, about what is and what is important in terms of comparability between the actual data that's being analysed. So We've got different ways of finding those equivalent questions. So some studies, very disciplined, very good data management, they name variables in CAPIs or CAPI names and things like that. CAPI is computer-assisted personal interviewing. So they're named consistently, particularly on panel studies are very, very good at this. So you can use that as a strong indicator that they're actually asking the same question. Some studies do that with variable naming, so that's one way of pointing back to the questions and then checking that the questions are equivalent. There's sort of traditional linguistic analysis, NLP methods. You know, you throw away all the are you, will you stuff and just concentrate on the housing size. That will tell you those two things are likely to be at least asking the same question, and at least you can assess that in the same way Jeremy was talking about having some human input into the machine, just giving you prompts for what would be linguistically equivalent. You can use machine learning methods to do the same sort of thing. If you've got a good training data set, and we've got a very good training data set, which we're exploring ways in which that can be done. And vocabulary tagging. So we also tag our questions and variables with a controlled topic vocabulary. So whether it's health or pregnancy or whatever. And so that narrows down the range in which you would look to see which variables would be potentially equivalent to improve the matching algorithms. So that's what I basically wanted to say. You can sign up to a newsletter. You can go and visit discovery.closer.ac.uk, which is our portal with 11 studies, longitudinal population studies in the UK. Or you could email us, or if anyone's still left in Birdland, at closer_UK.
Thank you, John. Comments or questions for John? Dan?
I knew I'd goad you into questions, Dan.
That was interesting, John. Thanks. And I have no argument with your definition of unemployed, but the three questions that you listed that sort of elicit whether someone's considered unemployed, I was thinking about what you had in the ordering. So the first question is, are you working, or do you have a job? Yes and no. Second question is, are you looking for work, say in the last 4 months? Well, you could conceive that question could be asked of people that also say yes to having a job. And I don't know how the U.S. Labor Force Survey, the current population survey, handles that. And with complex surveys, they'd probably fork and ask that question independently, because the universe changes depending on the answer to the "are you working" question as to whether how you're gonna ask the secondary one. But have you ever run into a situation like that where you have maybe a poorly designed question that's actually asked two different ways?
Yeah, so actually the reason that is a very, very good question is because that is a bit of a showstopper, not a showstopper, a fly in the ointment perhaps is a more accurate way of putting it, for some of the machine learning work we've been doing. So the machine learning work we originally were doing was just atomically at each question comparing another question. Say, are these two the same? Yes, it's fine. But then exactly the point you made, of course, where is it sitting inside something before? And, what is effectively the universe that's being done?
What was the previous question?
Yes, exactly.
Yeah.
So we're now pursuing is a frighteningly complicated, and the computer scientists get very excited about this stuff, more hierarchical machine learning techniques in order to account for that particular problem. So, I mean, that's sort of one of the things that this slide sort of picks up, is precisely those issues that, you know, what is, you know, it's how you really sort of define your concepts. Even something like age, you might want to define concept of age, you know, at birth or of something. So, you know, at age of first birth or something, whatever. So, you know, that makes it really, really quite complicated on the edges, particularly with modern questionnaires, which are generated by computer, which tend to be ludicrously complicated.
And I think that also that highlights the reason why starting with harmonizing conceptual variables at that very kind of abstract level is where we have to start, because once you start getting into the weeds of two seemingly similar conceptual variables, they might be asked very differently. In the MIDA study too as well, Dan, there was a protocol for assessing their job, right? It wasn't just a single question, it was a series of 5 questions, which resulted in a single summarized variable. Very complicated. Any other questions or observations for John? Okay, next up is Lucy. Lucy is a metadata manager at CDSP, the French Center for Sociopolitical Data at Sciences Po in Paris. She has a demographic background and is part of the data documentation and dissemination team. She has worked on an experimental project which aimed to build a question bank using DDI lifecycle and Collectica software. Today, she gives us an overview of the process of post-harmonizing the French electoral survey data using an established framework. Lucy.
So, hi everyone, and thanks Barry for this introduction. So, I'm very happy to be taking part of this session today for presenting a small project, we can say, like a pilot project we are working on at the CDSP. It's also a great opportunity to get an international perspective on the benefits and challenges of harmonization. So today I'm going to give you a quick overview of how we reuse an existing framework for post-harmonization to post-harmonize our French electoral survey data and metadata. So let's see how we do it. So firstly, I will start with a little reminder of the different perspectives of survey harmonization, even though I'm pretty sure that some of you are already familiar with them. But for those who are not, I will then illustrate the post-harmonization principle with an easy example. And after giving you a general idea of post-harmonization benefits, I will explain how we did it by using an established framework, the True European Voter Project, and also how DDI lifecycle variable cascade that my other colleague mentioned earlier help us to structure our workflow. Finally, I will conclude on the main outcome and the next step of this project. So first thing first, what are the different types of harmonization? So I won't go into an in-depth explanation of them, but what you have to keep in mind is that you can harmonize your data before or after data production and dissemination. And today I'm going to focus on the post-harmonization perspective, which allow us to make historical data from our French electoral survey collection more comparable. So two paths for post harmonization. Firstly, a bottom-up approach, which begin at the specific to move to the general. So from my experience, I can say that this one can be really challenging when you want to bring together several studies. And secondly, a top-down approach, which goes from the general to the specific. In that case, a defined framework is really helpful, I should say mandatory, to achieve post-harmonization. Okay, so let's take an easy example to show the benefits of post-harmonization. So these are fairly common variable for measuring objective size of town you can find in most surveys. And as you can see, the label and the categories are not directly comparable between these two surveys. So since they capture the same concept, we have created a new variable gathering a category of both original variable. But it, so for one or two survey, it seems easy to do, but it becomes more complicated when you want to compare several studies with a large number of variables. So as I said earlier, our solution was to reuse an established framework. And actually, we were quite lucky to find the true European projects, which involve 23 countries and set up common data harmonization guidelines for European electoral survey data post-harmonization. And this project covers 12 concepts and more than 50 sub-concepts. As you can see on the left part of the slide, you can see a part of the conceptual tree from the Explore page of our Collectica portal. And it also includes other initiatives, for instance, the Manifesto project, which is a project for political party harmonization. So the True European Voter project was led by Herman Schmidt, and the database and the codebook is available on the GESIS website. Briefly, how did we do in practice? So firstly, we extract all the variable from DDI, codebooks, XML file, and then we have manually attribute the TOV concept and subconcept. We then create a new conceptual variable level to refine the concordance variable. And connecting a variable to a concept and a conceptual variable make it easier to find information in many studies. And this metadata base helps us to automate part of the data recording workflow to fit with the guidelines of the TOV codebook. So yeah, data harmonization, as I said, has been achieved through the metadata harmonization by using DDI lifecycle construct and also the TOV ontology. So one of the main tasks was manual classification. That's why it could be also a good thing to have AI tools to help us to do this work, because it can be really time consuming, and depending on the number of the variable you want to harmonize. Reusing an existing ontology also has its limits. Firstly, the TOV categories are not really exhaustive and they are not covering all the French survey specificity. So that's why we have to create a new concept and subconcept. And we also enhance granularity by creating the conceptual variable level. So the two main outputs are the production of two databases. On one hand, a bilingual metadata base of 3,000 variables from 11 surveys since 1958. So with approximately 2,500 variables concordance to the TEV concept. On the other hand, an harmonized database of more than 400 variables and over 30,000 individuals. So. And it covers the French election of the Fifth Republic. So it's really useful for our users because this study are the more requested ones of our catalog. So yeah, to conclude, the next step are to refine the TEV ontology according to the French survey concept. It's ongoing work. Also to complete curation by building relation and concordance in Collectica, and as Jeremy says, like we want to use a metadata input sheet because I did it manually with designer actually. And yes, and also we want to, because as I said, like the French electoral survey are very rich, but also very heterogeneous survey, and we want to raise awareness of prospective harmonization among researchers. So yeah, that's all for me. Thank you.
Thanks, Lucy. Any questions, observations for Lucy? Okay. Oh, John?
How many new concepts did you have to create?
Ooh,
How many new concepts did you have?
it's actually a work in progress because we are working like also with researchers like Nicolas Sauger, which is a director of the CDSP, and he is a researcher in political science, and also we have worked with a PhD student, because I think like the researcher perspective is really important when it comes to define concept and linked existing variable to concept. So I don't have a precise number today to give you, but
Did you have to create a new top category?
not really, because we did it with the conceptual variable level. We have like two levels of concept and a third one with conceptual variable. Yeah.
Anybody else? Okay, thanks, Lucy. Our last presentation is from the perspective of a researcher. Dr. Nancy Kassam-Adams is a psychologist and research professor of pediatrics at the University of Pennsylvania, Perelman School of Medicine. She is based in the Center for Injury Research and Prevention at the Children's Hospital of Philadelphia and directs the Center for Pediatric Traumatic Stress. Her program of research over the past 25 years has focused on understanding how children and families respond to potentially traumatic events such as injury and violence, and on developing effective secondary prevention methods with wide reach. Dr. Kassam-Adams leads several international collaborative efforts to advance data sharing and fair data practices across the field of traumatic stress research.
Thanks, Barry. I think we decided that I would go last because I'm sort of something different. So I think what this presentation brings is the perspective of a researcher, so I'm still doing actual research, but also someone who's originally accidentally, but continually intentionally fallen into doing data sharing and data archiving work. But as everyone else was talking and as we were preparing, I see a lot of overlapping themes and then some key differences. Hopefully it'll help illuminate things. So as Barry said, I've led, over the last 15 years or so, a couple of international collaborative groups that are trying to bring data together and make it possible to integrate data sets so that we and others can use these for novel analyses to learn new things around child trauma. So the Child Trauma Data Archives began with a set of prospective studies, so children who'd been identified on the basis of their exposure to some kind of acute traumatic event, often in hospital settings, but sometimes in community settings like disaster, and then followed over time. So longitudinal-ish, in that this often goes for months. The longest follow-up tends to be maybe a year or sometimes more than that. To be included in the archive, data had to have more than one assessment point and had to focus on identifying kids based on exposure and then some kind of trauma or traumatic stress outcome. And I've said to various people that we started this as a project to bring 9 data sets together for a particular, to build a tool. It wasn't supposed to be an archive. And we spent all of our time, not surprisingly to most people in this room, actually just figuring out how to bring the data together, literally at the level of variable names, and then, of course, at the level of concordance, even though we all studied essentially the same thing. We ended up bringing together, over the years, more than 30 data sets, and you can see the sample sizes of our studies by the fact that it takes us 30-plus data sets to get to 5,500 kids. But these data have been used in master's and doctoral theses. They've resulted in peer-reviewed publications. So we've created a resource that's getting used in the field. And valuable enough that we've moved on now to creating an intervention archive. We're just in the midst of bringing in intervention studies to sort of do a proof of concept with about 25 of those studies to show that we can also look at concordance there. So what I thought I would talk about briefly, and I think maybe we can reflect together on the similarities and differences to big surveys, a little bit of the scope of the task in our field, which I think might be similar. There's some special things about it being trauma and traumatic stress, but some things that are similar to other, what's sometimes called the long tail, lots and lots of small N studies in a field with rich data where we could benefit from bringing them together. So scope of the task, I'll give you just 2 brief examples of some of our harmonizing or making data harmonizable challenges and things we've done, and then just 2 reflections from a sort of research community perspective. So here are some of the part of the scope of the task, a lot of which overlaps with all the other talks we've had today. You know, figuring out how to bring together demographic data, particularly across countries. We have the special needs in our field to somehow characterize what was that trauma, what were people exposed to in some common way. Most of our measures are standard validated measures, as opposed to sort of made up for the survey measures. And so rather than starting from questions, we tend to start from here's an interview that is done in a standard way, or here's a questionnaire that's been validated. I will say, I don't know if you noticed this number on the last slide, in our first 30 studies, with our focus being child trauma and child traumatic stress, there were 22 different measures of child traumatic stress. So big harmonizability issues. We can't seem to agree as a field on just a few measures, and those are all perfectly good, validated measures. So we have a whole range of standard validated measures. We sometimes have also physiological measures of various kinds, or things that come from health records or medical records, occasionally things like school records. And then very important for traumatic stress trajectories and looking at symptoms over time is how do we characterize time? So we spent a lot of time on the phone. This is pre-Zoom years. Lots of smart researchers from around the world just talking, maybe not arguing, but talking about how are we going to characterize the time since trauma for each kid's assessment, or the time now in intervention studies, time since intervention baseline. And then as we moved into intervention studies, there's a whole new range of things we're having to figure out how to deal with, including intervention content, delivery, and things like that. So just 2 examples, kind of similar to questions. We have gone down to the item level. So most validated psychological scales can be used at a couple of different levels. You can score them and just get a total score. We could have an archive that just saves those total scores, but that would be throwing away a whole lot of information. Many also have subscales, categories within them of different aspects of anxiety or traumatic stress or depression or you name it. And then, of course, there are the single items. And in terms of level of granularity, it was pretty clear to us that those single items were most important because they can sort of be mixed and matched in different ways to ask new questions. So here's just an example of what we've done, starting with a scheme of a standard diagnostic the DSM, the standard diagnostic manual for post-traumatic stress or depression or different anxiety disorders, looking across the 20 plus, 30 plus measures and lining up every single item that matches up to that symptom. Sometimes that's pre-specified by questionnaires, but not always. Sometimes it's more than one item for a given symptom. And this is just a little picture of, 6 or 7 measures and one symptom. You can imagine that for the over 60 item measures that we've got for different. So we have big tables of this. We provide templated syntax to help people bring this together. There's a lot of decisions later researchers might make about how to use these in different ways. We're trying to just create the possibility of harmonizing. As we've gotten into intervention data, one of the trickier things was how to code the intervention content, both what's done in a given study, also what an actual participant receives, so 2 different levels, study level and what that person gets, but those are super important for doing comparative studies. And so we could be simply looking at that top way less interesting level of, is it a psychological intervention or a pharmacological intervention? For kids, there aren't too many pharmacological, that'd be very uninteresting. There's broad sort of families of interventions. Again, there might be some new questions where that's of interest, but we really need to get down to a little more granular level. There's a lot of sort of brand names, that have been developed, manualized treatments as such, and we certainly have those coded. But what we realized is that there was a literature about the actual sort of the ingredients in those manualized treatments, and so we've been we again went through an expert consensus process to establish what should those practice elements be, and we're now coding every intervention so that again. People could be looking at these interventions in new and different ways. So just 2 observations, I guess, as a researcher who, I've been in the business now of bringing data sets together and sending them out to other folks, but who also might be using these data. Harmonization choices or what is possible in a given data set is completely intertwined with the kinds of analyses I can do or the questions I can ask. And so it's really, really important to think about the available data, what that leads to being feasible to harmonize or made harmonizable, and then what kind of constraints that might place on analysis strategies or the new research questions we could ask of those data. We can't always get it right, and we can't be perfectly granular, or you can do this forever, but being smart as we consider the level of granularity at which we preserve data, the level of granularity for really high-quality metadata, I think are just crucial for ongoing actual meaningful reusability of data. And then as a research community, I think we've heard a few people mention this before. Here's the variable cascade again. What's becoming increasingly clear to me is that that top level, that concept, is not trivial at all and can be difficult. It's simpler for things like height, perhaps. It might seem simpler even for did you have nightmares after your trauma? But if we don't agree on that, then our project could do an incredibly good job, someone else doing another project could do a very good job, and if those things don't line up, we as a research community of traumatic stress researchers won't be able to get the most value across all those different projects. So a real need to get that right as a community. No one project or researcher can do it. And then to create these as formal, machine actionable, referenceable ontologies that can be used by systems like DDI or the DDI-CDI. And that's a job, I think, for communities, not necessarily for the technologists. And so that's beginning to happen just a little bit in my field. Another hat that I wear is leading the Fair Data theme in what is a coalition of 11 scientific societies that all deal with traumatic stress in one way or another. We have a bunch of sort of tools and infrastructure projects, like just trying to build an index of the potential data resources out there. There's no one place you go to find data like these. And then a number of integrative data projects, including ours, and the crosstalk amongst people doing, traumatic grief, us looking at child trauma, other people looking at adult trauma treatment, or at veterans, and there's others, has been really important. And I think that's where the coming together on common ontologies and ways of doing this work is going to come from. And I imagine that might be true for other research fields or communities as well. And I will leave you there. The slides I know will be available, so I've put some, I think, useful links to the projects, as well as some really useful readings and references in this area. This is just a poster that in Belfast in a couple of weeks. We tried to get 2 traumatic stress conferences that we're going to anyway, and then preach the gospel of fair data. So we have a little how to do fair data poster at a trauma conference in Northern Ireland in a couple of weeks. Thanks.
Thank you, Nancy.
Questions or comments for Nancy before we assemble the panel?
Thank you very much for your interesting presentation. And it's also very interesting to see how you can use like concepts and components from DDI in your work, and also bringing in new perspectives. So that is very much appreciated. And also what you were talking about these intervention categories and things like that. That is kind of new and something that could be brought back to our community to look further into.
Mm-hmm.
So thank you very much.
Yeah, thank you.
Yes.
Thank you, Professor. I have a question related to your concept, because you mentioned you want to build up a database for flexible use, and I know little about this, so forgive me if I misunderstood you, but I want to know, does that mean you want to, harmonize all the 30-ish data sets together, provide as many as possible variables? If that is the case, where it causes a lot of missing values or missing cells in the database,
Mm-hmm.
and would that be a trouble for users, or is there any?
Yes, absolutely. So yes, we are trying to do that, as many
happens.
variables as possible across the 30-plus data sets, and all is, we don't see this as finished. It's a matter of staff and time and funding, of course, but we've created a system that we could keep bringing in all the prospective child trauma studies that ever get done, and hopefully soon all the intervention studies. And our colleagues hope to do this for all the traumatic grief studies. But you're right, then things are missing by study, and you have to think in your analyses, do you include in the analyses study as a variable, as a covariate? Do you decide that there's no one way to handle that? But indeed, that can be challenging.
And I assume if this is a huge database, then maybe from the user side, because I'm data librarian, sometimes we need to guide people how to use the database. You are not going to download the whole database. You have to customize based on your online infrastructure or something like that.
Yeah, thanks for that question. So we actually, yes, again, this depends on staff and time and funding, but so far, when people request a data set, we work with them to figure out what variables do they actually want, and we create a custom data set that pulls from, again, sort of this mix and match. If you want to look at sleep and nightmares and child age, we'd be pulling those variables and other covariates across as many studies as have them, with a whole lot of metadata and information about the studies and how they were collected and all the things that John mentioned, so that people know where these came from. Yeah, the future, I had it on a slide, but it was just very small. We are actually in the process of getting permission from all the original investigators, and we will get this prospectively going forward, to deposit these data sets with a new collection at ICPSR in a different, not NACTA, but DSDR, because of the way we're funded. There'll be a similar request process, but people will get a data set at a time. And I think that we will still need to be helpful on the side when people get whole data sets to figure this out. Yeah.
And with that, I'm going to actually ask all of the panelists to assemble at the front table, and keep an eye out for Sanda's glasses, which are probably on the floor.
Don't wear them now.
Scratching noise.
Are there any questions for the panel?
I have a question for John, because you mentioned that you use the machine learning in your metadata creation, so you used traditional machine learning and also like topic modeling machine learning in the metadata. I am just curious, how do you find how helpful machine learning in the metadata creation process? Is it a real helpful tool for you to create metadata by using machine learning techniques? Because a lot of times, machine learning, no matter it's supervised or unsupervised, it creates clusters of topics for you, but sometimes the way the machine understands the topics is different from people categorize our subjects. So how do you work with both the human categorized like metadata and also the machine learned metadata? If there are like a lot of differences between these two parts, how are you going to make decisions for the metadata creation? Thank you.
So, is this working? Yeah. The metadata we hold includes the questions, the variables, some topic tagging. And we've used that as a training data set. So we've got, now I've completely forgotten how many variables we've got now. I think it's 190,000 variables and questions, pretty much similar number of questions, which is a substantial data set to use. We're still in relatively early days in terms of testing the prediction validity and so on. Of the approach, and as I mentioned earlier, we've recognised already that there are some fundamental problems with trying to do this. So I think the short-term ambition is, we would like to get to a position where you would, red, amber, green, 90% of the time you're probably going to be right. And then add that to the list if it's wrong. And the other thing is to then develop new methods that work around some of the known issues. And one of the issues is the point that Nancy mentioned, where you've got, particularly where you've got the same question appearing in completely different concepts, and then they're bubbled up into a large sub-concepts. They're bubbled up into different concepts. That's a really problematic thing for anybody to do, let alone the computer. So there are a lot of challenges to that. Yeah, I mean, I think we can get to the point where we can take a lot of the pain out of it, because everybody on this panel has spent, well, Jeremy probably, everyone on this panel has spent a lot of time looking at bits of paper, manually allocating things to concepts, and to be honest, I wouldn't wish it on my worst enemy. It's not a great deal of fun. So I mean, from my perspective, that's my thing, is really to take the pain out of that and get as close as you can, and know you just have to have a human somewhere in the loop.
Any other questions?
I think you all mentioned that you use the variable cascade either in lifecycle or in DDI, CDI. And I would like to ask if are there other aspects of DDI that you find particularly useful in your work?
In this type of work, Hilda, like the harmonization work?
As I said, at the CDSP we have documentation in DDI codebook, and it was useful to extract all this information from structure XML to put them in an Excel spreadsheet. And I mean, it's not 100% interoperable, but the structure, the XML structure, makes them also allows us to to match information and to work, to automate a part of the process. So, yeah.
Does that work, Hilda? Anyone else?
I think just one comment. The other parts we see people using a lot are certainly the study unit, groups of study units, coverage, especially time coverage to lay out when are the different waves of a longitudinal study, for example. At the high level, you have all of that available in DDI. And then getting to the lower level, a variable is not just a variable. Of course, you have code lists, categories, and all that, and those can be very useful for determining what might be comparable or not, too.
So I think basically what Jeremy is saying, and I'm just picking up on it, is the possibility to link across not just variables, but code lists, cross-reference. This is really useful because this is how you show relations.
Maybe just another observation too, in my experience. Well, I think this applies more broadly to the research data management field, is that it can be very intense work and you have to devote a lot of resources to it. And especially from a data producer's or a researcher's perspective, what's in it for them? If they have to just come up with a DMP that satisfies the grant requirements and then they submit it to a repository, what other motivations are there for them to actually document their data well? And I was thinking when I was demonstrating the MIDAS concordance table in our harmonization in the Collectica portal, people thought it was great, but then they asked how we actually did it. Like, was the portal able to actually pull all of those variables in and determine which ones were harmonized? I said, no, it required a lot of legwork. You could see interest just drop, right? No, so I guess where I'm going is coming back to the artificial intelligence ML angle. It's also fraught with complexities, just like the rest of this, this topic. But is there a way that AI ML can kind of, do some of the heavy lifting? And I think Jeremy and Dan, your work's headed that way.
I mean, just more broadly, I think one of the things that having stuff in metadata in standards means you can use the same tools across, a whole discipline. So and that is quite powerful because it means you can develop tools that are reusable across different disciplines, and automate stuff in a way that is not possible if you've got in 1,000 different formats. I think the world is moving towards, hopefully, moving towards a world where there's an incentive for researchers to collaborate doing those sort of things, rather than an incentive to not collaborate and use standards and use shared code and things like that.
And as I said in the opening remarks, hopefully using a metadata standard gives some structure to what can be a really messy and resource-intensive process. Just one other observation. Nancy had talked about how just defining and harmonizing concepts sounds like it should be really simple. These are really similar variables. What about history of maternal smoking? Would AI recognize that as a maternal health issue or an infant health issue or maybe even like an environmental issue? And in some of the work that I've done with Collectica, we've realized that you have to have one-to-many relationships with some of these harmonized variables.
And I'm just getting to know that. I think that's the role for creating really formal machine actionable ontologies. We're with all those definitions, all those interactions very well defined, because it might very well be both a maternal variable and a health variable, and you want to be able to treat it both ways and be flexible. I was thinking, Jeremy, your last point about targeted, like something to target to. So if indeed we could have that reasonable ontology or taxonomy to point at, as opposed to, I think as a researcher, I'm there's a lot of things machine learning can do, but to have it come up with the concepts for me might feel a little foreign, but to have it match variables to the concepts I want to look at or that my field thinks are important would be great. Yeah.
Anybody else? Is there anything online, Sarah? Okay. I think we'll call it a day then on that. I want to thank the panel and thank everybody for participating. Thank you.